Chapter 6.5 Inequalities in Two Variables and Systems of Inequalities. Okay, let's first of all, let's graph an inequality like this in example 1. Okay, when we graph an inequality, this is a linear inequality because the degree of x and y are 1s. So when we graph this, we need to first graph the straight line. Since the inequality does not contain the straight line, does not contain the equation, the straight line will be a dashed line. And if the inequality contains something like, the inequality contains equal sign like this, then the graph will be a solid line. If it does not contain the equal sign, just like this, then the line will be a dashed line, the dotted line. Okay, so first let's make this one as an equation. Let's make it as an equation and then graph the straight line first. So this is x-axis, y-axis. Okay, when we graph the linear equation, the straight line, we will find 2 points and connect. So the best point in this case is find x-intercept and y-intercept. Okay, let's find x-intercept. X-intercept is set the y value equal to 0. So if y equals 0, then what happens? If y equals 0, then 3x plus 0 equals 12. So 3x equals 12, and then x equals 4. So we found x-intercept. X-intercept is 4 and 0. So 1, 2, 3, 4, 0. This is the x-intercept. And let's find the y-intercept. Y-intercept is, you can set the x value to 0, then find y. So x value is 0, so 3 times 0 plus 4y equals 12. So y equals 3. So that's the y-intercept. So x equals 0, y is 3. 1, 2, 3. Okay, so since we found 2 points, we can graph the straight line for this equation. And there's no equal sign. The inequality does not have an equal sign, so we will draw a dotted line connecting these 2 points. Okay, so this is the straight line equation of linear equation. I meant the line for the linear equation. Okay, the inequality is either above the line or below the line. We have to select either side of this line. So the best way is to test a point. So why don't we test any point is fine. So the best point is 0, 0, because we can use the values of x and y as zeros. So in this case, we will test a point. So we will use 0, 0, then plug in 0, 0. So test a point. Let's test 0, 0. Then the inequality is 3x plus 4y is greater than 12. So from this, x equals 0, y equals 0. Then we get 0 is greater than 12. This is not true. This is false, right? False. Not true. So 0, 0 is not a solution. Then the solution is the other side of the line. So we will shade above the line, the area above the line. So this will be the solution. Okay, let's try another one. Okay, example 2 is graph this inequality. And this inequality is non-linear inequality because the variable x is square. So this is a quadratic inequality. So first of all, let's make an equation, and then we will graph this quadratic equation first. And for the inequality, graph of inequality, we will select the area either above the graph or below the graph. Since this is quadratic equation, let's find the x-intercept and the y-intercept. Okay, so why don't we factor this one? So x times x, 1 times 3, the negative sign is here, so this will be negative x, this will be 3x, and then 2x. So we can rewrite it as a product of x minus 1 and x plus 3. The reason I did is I want to find the x-intercept. So from this, the x-intercept is, okay, let me write it here. The x-intercept is set the y value equal to 0. Y value equal to 0. So what we have is x minus 1, x plus 3 is equal to 0. Then x equals 1. We will set each factor equal to 0. So from the first binomial, x equals 1. And from the second binomial, x equals negative 3. So we found x-intercept. Not this one. So we found x-intercept. That is when x equals 1, y equals 0. And x equals negative 3 when y equals 0. Okay, and then let's plot this one. Okay. So x is 1, y equals 0. X is negative 3, so 1, 2, 3. Then y equals 0. So we found two x-intercepts. Okay, let's find the y-intercept. Y-intercept, we can get the y-intercept by setting the x value equal to 0. Since x equals 0, what happens? Okay, from this, y equals 0, so y equals 0 plus 0 minus 3, so y equals negative 3. So that's the y-intercept. So y is when y equals 0, when x equals 0, y is negative 3. 1, 2, 3. Okay, 1, 2, 3. Negative 3. That's the y-intercept. Okay, then let's find the vertex. The vertex is between, the x value of the vertex is between the x-intercepts. So it's gotta be, get the x-intercept, the distance of x-intercept is 4. So divided in half is, divided by 2 is negative 1. So that's the axis of symmetry. This is the axis of symmetry. And then let's plug in our f of negative 1 so that we can find the vertex. Since x is negative 1, negative 2 times, let me write it here, negative 1. So negative 1 minus 1, negative 1 plus 3, then negative 2 times 2, which is negative 4. So the vertex is when x equals negative 1, y is negative 4. So let's say this is negative 4. Okay, then the graph should be something like this. Actually, this is not drawing in scale. So this is quadratic, so it looks like this. Okay. And then from this parabola, we will select the area either inside the parabola or outside the parabola. So why don't we test a point which is 0, this guy. So test a point. Test a point. In this case, we will test 0 and 0. And the inequality is y is less than or equal to, y is less than or equal to x squared plus 2x minus 3. So let's plug in 0, 0. Then this will be 0 plus 0 minus 3. So 0 equals less than negative 3. And 0 is less than negative 3. This is false. False. That means this is not a solution. Not a solution. So the solution will be the other side. So the 0, 0, the origin is not a solution. So which means inside the parabola is not a solution. So the solution will be outside. Okay. And then the graph is a solid line because there's an equal sign here. Since there is an equal sign, we will use the graph will be solid line, which means the line, the curve is also, the curve is included in the solution. Okay, example 3, graph the inequality, this inequality is an absolute value inequality, because we have because x is an absolute value. So let's first make it an absolute value equation and then graph line. And then as we know there's equal sign, so the graph will be a solid line. And then let's use translation. So why don't we use the translation? So okay, absolute value of x is this one. This is absolute value of x. And then we will translate this one 1 unit up. Because plus 1 means 1 up. So we will shift. So why don't I write it here? Shift y equals absolute value of x 1 unit up. Shift the graph of absolute value of x 1 unit up. 1 unit up. Okay, 1 unit up. So here it is 1, and then the graph will be, okay, this is a solid line, solid. Okay. And then the graph will be, since this is an inequality, we will select the area either inside or above or below the line. So let's test a point. Test a point. The best one is 0, 0. And always the point is it should not be in the line. It should be outside the line. So let's try 0, 0. Then y equals, from this inequality, plug in 0, 0. So 0 is greater than or equal to 0 plus 1. This means 0 is greater than 1. 0 is greater than 1. This is false, right? False. So 0, 0 is not a solution. 0 is not a solution. Then what? The other side. The other side is the solution. So 0, 0 is not a solution. So the solution area will be inside. Okay, example 4. This is a system of inequalities. So graph the system of inequalities. Okay, for this one, okay, there are 2 inequalities, which means we will select the common area. So the common area, the overlapped area, will be the solution of this system of inequalities. So let's graph each inequality. So from the first inequality, okay, let's make an equation. And then from the second inequality, let's make an equation so that we can graph the straight line. So from the first one, okay, from the first one, let's find x-intercept and the y-intercept. Find x-intercept and y-intercept. Okay, so the x-intercept is, okay, x-intercept, set y equal to 0. Set y equal to 0, then what is x value? If y equals 0, then x equals 2, right? How about y-intercept? Set x value equal to 0, x equals 0, then y is negative 3. So x equals 2, 1, 2, y is 0. X-intercept, y-intercept is x equals 0, then y equals negative 3. And then the line is dashed line, because the inequality does not contain the equal sign. And let's use 0, 0 as a testing point. If it's 0, 0, then what? Plug in 0, 0. So 0 is equal to 6. I'm sorry. So from the original inequality here, 0 is less than, 0 is greater than 6. This is false. So the solution will be below this line. Below this line. Okay, let's find the graph of the second inequality. Okay, x-intercept. The x-intercept is set y equal to 0, then x equals 5, y-intercept. X value is 0, then y is negative 2. So we got these two. Okay, y equals 5 and x equals 5. 1, 2, 3, 4, 5. That's the x-intercept. Y-intercept is negative 2. This is the y-intercept. Let's use a different color. So we'll connect these 2 points. This is, okay, there's equal sign, so I should use a solid line. Solid line connecting these 2 points. All right, and then let's test point 0, 0. So test 0, 0. And then 0 is less than or equal to 10. Is this true? Yes, this is true. So we will select the area that contains 0, 0. So that will be above the line. Above the line. So from this, because this is equation 1, this is inequality 1, this is inequality 2, the line. So the solution will be the common area. The common area is below this dotted line and above the solid line. So the solution will be this part. And the solid line means solid line is included. This line is included, but this line is not included. So this is the solution area. Okay, exercise 5 has given us a system of inequalities, and this is related to the heart rate. Okay, y represents the heart rate per minute, and x is the person's age. So, and the person's age is given from starting from 20 to 70. So the domain is given. So why don't we use a graph starting from 0? So x represent the age, and y represent the heart rate. So this is, let's say this is 20. This is 20, and let's say this is 30 or 70. Okay, the first equation is when x, from the first equation, when x equals 20, let's find y. If x equals 20, then y should be y equals 0.0 times 200. So 120. So let's say this is 120. Then when x equals 20, y equals 320. Okay, how about from the first equation? Okay, if y equals, from the first equation, if y equals x equals 70. If x equals 70, let's find y value. Then 0.6 times 150. Then there will be 90. So if x is 70, then y will be 90. Let's say this is 90. Okay. So since, and then let's cut this let's cut the line. Okay. So when you cut the line, you can use this little, this cutting sign, like this. All right. So the graph will be something like this. Like this. This is the graph of the not yet. This is the line of the first inequality. And then the area will be above the line, because if we plug in 0, 0, 0, then 0, 0 is false. 0, 0 is false. So the solution will be above this line. Okay, then from the second inequality, let's use x equals 20, and then let's find out the y value. 0.8 times 200. So that's 160. So let's say this time this is 160. And that's the point when x equals 20. If x equals 70, then y equals 0.8 times 70, so 150. Then this will be 120. Okay, 120. So it's gonna be somewhere over here. And the graph will be like this. Okay, and then the area will be, if x equals 0, 0, then plug in 0, 0. Then that's the, is it? This is less than or equal to, so plug in 0, 0, then means below the line. So we will select the area below the first line and then above the first line. So actually, everything in this area will be the solution of this system of inequalities. Okay, then from this one, they are asking, okay, determine the targeted exercise heart rate range for Emily, who just turned 30. So if an age is 30, then what would be the range of this person, heart rate range for this person? So if x equals 30, then let's find out from the first inequality, let's find out the y value. Okay, the y value is 0.6 times 220 minus 30, then 0.6 times 190. Okay, then this will be equal to 114. So the heart rate should be 114. From the second inequality, y is equal to 0.6. Okay, not this one. Okay, from the second inequality, yes. Yes, from the second inequality, that is 0.8. 220 minus 30. So 0.8 times 190, then 152. All right, so if a person's age is 30, then the range should be in this, should be between these two lines, between these 2 points. So the y value for this is, when x equals 30, the y value is 152 for this one. If the age is 30, then the heart rate will be 114. So y should be between 152, less than 152 and greater than 114. So this should be the range of the heart rate for the person whose age is 30. Okay, example number 6. Okay, graph system of inequalities. The first inequality is a hyperbola. Okay, so x squared minus y squared is less than. This is the inequality of hyperbola. So let's make an equation and then divide each side by 9. Then this will be 9 minus y squared over Then finally, this is equal to x squared over 3 squared minus y squared over 3 squared is equal to 1. Alright, so this means a is 3 and b is 3. So if we graph this, x comes first. So the graph should be something like this, right? Something like this. And this is center. This will be 3. This will be 3. And the focus will be this length. So probably around here. Something like this. And then the asymptote is, the slope is rise over run. So 3 over 3 is 1. So mx. So that is this asymptote. So if you graph it like this, then there will be x equals 3, 1, 2, 3, 1, 2, negative 3, and 3. And the asymptote will be y equals x, This is the asymptote of the hyperbola. And then the focus is this one. The vertex is this one. So the graph will be something like this. There's equal sign, so it's gotta be a solid line. Solid curve. Equal sign, so solid curve. All right. And then the area should be, is it between the curve or outside the curve? Okay, let's check up. Let's test a point. Let's test a point which is 0, 0. Okay, let me erase this one. Okay, 0, 0. Then 0. Okay, from the inequality, x squared minus y squared is less than 9. 0 is less than 9. Is that true? Yes. So this is a solution. That means inside. Actually the inside, between the curves is the solution area. So everything between the curve. Everything between the curve is the solution. All right, then let's graph the second inequality. The second inequality is 2x plus 3y is greater than 12. This is linear inequality. So 2x plus 3y is equal to 12. Let's find x-intercept. Okay, x-intercept is when y equals 0, then x equals 6. And the y-intercept is, okay, let me write on the next line. When x equals 0, y is 4. So let's use a different color. So x equals 6, y equals 0. X equals 6, let's say this is 6. Y equals 0, that's the x-intercept. Y-intercept is x equals 4. So let's say this is 4. So we will connect these two points. And then there is no equal sign. The second inequality does not have an equal sign, so the line should be dashed. Dashed line. And then let's test the point. Test a point which is 0, 0. Then 2x plus 3y is greater than 12, x equals 0, y equals 0, then we have 0 is greater than 12. This is false. So the solution will be the other side. 0, 0 is not a solution, so the solution will be the other side, above the line. Above the line. Okay. And then since we have two inequalities, the solution will be the overlapped area. So the overlap area is between the curves and above the line. So between the curves and above the line, the common area should be, this is above the line, right? Above the line. And then above the line and above the curve, between the curve. So it's gotta be this part is the solution. So this is the solution area. Okay. Okay, this is a practice example, number 6. Okay. This is not in your textbook. Alright, so the first inequality is what is this one? Isn't it ellipse? This is plus, right? Plus means ellipse or circle. Okay, so if we make an equation, then this is an ellipse. You divide each side by 4. Then this is x squared over 2 squared plus y squared over 1 squared. So this is an ellipse, isn't it? Ellipse. Alright, this is an ellipse. So the longer side, the major axis is x. So why don't we graph on the number line? Okay, let's move it over here. X-axis, y-axis. Okay, this means a equals to major axis is 2, minor axis is 1. Alright, so the graph something like this. There's no equal sign, so the graph will be a dotted line. It will be a dotted line. Okay, it looks like this. And the area is, okay, let's use a 0, 0 test point. Let's test 0, 0, then 0 x squared, then x squared plus 4y squared is greater than 4. That means 0 is greater than 4. Is this true? That is false. So we will select the outside the area, outside the circle, outside the ellipse, outside the ellipse. Okay, so we will select the area outside the ellipse. Outside the ellipse will be the solution of this ellipse inequality. Okay, how about the second inequality? The second inequality is linear inequality. X plus y is less than or equal to 1. The solid line. So make an equal sign. And then let's find the x-intercept and y-intercept. X-intercept is when y equals 0. Y equals 0, then x equals 1. Y-intercept. X equals 0, also y equals 1. Alright, so let's use a different color. X equals 0. Okay, this is the x-intercept. This is the y-intercept. And there's equal sign, so we will draw a straight line. And then let's test the point so that we can select the area. Test 0, 0. Then 0 plus, okay. Then the inequality is x plus y is less than or equal to 1. So 0 is less than or equal to 1. This is true. So we will select the area that contains 0, 0. So 0, 0 is the solution. Wait a minute. Let me double check. Okay, so 0, 0 is solution. So we will select the area below this line. So below the line and outside the circle. So the common area is below the line and outside the circle is this area, right? All the area over here, including the solid line. So that is the solution of this system of inequalities. Okay, example 7. Okay, let's try this graph. Okay, the first one is x squared plus y squared. Since this is plus, this is either circle or ellipse. And then divide each side. Okay, let's make an equation first. And then x squared over 16 plus y squared over 16 is equal to 1. And x squared over 4 squared. This is a circle, isn't it? This is circle. So we don't even have to do this one. This is circle. This is x squared plus y squared is equal to 4 squared. So the radius is 4. The radius is 4. X, y. I'm sorry, the radius is 4. So let's say this is 2, 4. Negative 2, negative 4, negative 2, negative 4, negative 2, negative 4. And the graph will be solid line, a solid curve. This will be the solid circle. Okay, let me circle this one. All right. And let's test the point. So this is a circle. Let's test the point. Then 0 is less than or 16. That is true, isn't it? So test the point. So that means starting from using the original inequality, plug in 0. So this is true. So the solution will be inside the circle, including the line. All right, and then let's try the second example. Inequality. Second inequality is x squared minus y squared is greater than or equal to 36. There's equal sign, so the curve will be solid. Okay, this is a minus, so it's a hyperbola. This will be a hyperbola. So actually the equation will be hyperbola. Right? Then divide each side by 36, so this will be x squared over 6 squared minus y squared over 6 squared is equal to 1. Hyperbola. So a equals 6, y equals 6. So 2, 4, let's say this is 6. This is negative 6. Then the asymptote is a over a. Asymptote is y equals, the asymptote, the slope. Actually, the slope is rise over 1, which is 6 over 6 is equal to 1. So the graph of the asymptote will be y is equal to mx plus b. The y-intercept is 0, so y should be equal to x. So that's the asymptote plus minus. Asymptote is plus minus actually. And the vertex is 6. We know the vertex is 6. 6. So, okay, let's use a different color. So the graph will be something like this. Okay, then let's test the point so we can find out the area. Test 0, 0. Then x squared minus y squared is greater than or equal to 36. 0 is greater than 36. Is 0 greater than 36? No. This is false. So we will select the area outside. So outside the other side, actually the other side, which means this is the side that does not contain 0, 0. So the solution is outside, not between these two hyperbola curves. So as you can see there's no common area. In a circle, the first inequality, the solution for the first inequality is inside the circle. And from the second inequality is outside the parabola. And then as we can see there's no common area. So we can conclude that there is no solution. This means there's no common area, no intersection, which means no intersection. So that the system has no solution. So the system has no solution because there's no common area. Okay, let's try this practice example. Okay, the number 1 is the inequality. This inequality is a circle, isn't it? Because can make an equation. Then x squared plus y squared is equal to 25. 25 is 5 squared. So this is a circle with the radius is 5. So if you graph it, 5. So let's make it 5, 5, 5, 5. Okay, then let's graph a circle. You see solid line? It's not a solid line. It's gotta be a dotted line. So using a dotted line, draw a circle. Okay, I'm doing my best to draw a circle. Okay, here's a circle with a dotted line. And let's test the point so that let's find out the area. Test 0, 0. Then 0 x squared plus y squared is greater than 25. From this inequality, when you plug in 0, then this is false. So 0, 0 is not a solution. 0, 0 is not a solution, so the solution will be outside the circle. So the solution will be outside the circle. Okay, outside the circle. Alright, let's try the second inequality. The second inequality is, okay, this time this inequality is an ellipse. So let's make an equation first. Divide each by 16. Then x squared is equal to 16 plus 4y squared is over 16 is equal to 1. Then x squared is equal to 4 squared, and then y squared over 4. Okay, 4 is 2 squared. So a is 4 and b is 2. This means the major axis is 4. Minor axis is 2. Major axis is 4, so let's say this is 4. -4, and minor x is 2. This will be -2. This is an ellipse, and the ellipse is a solid line, solid curve. Like this. Okay, then let's test the point. So let's test 0, 0. Then x squared plus y squared is less than or equal to 16. 0 is less than or equal to 16. So this is true. So we will select the area that contains 0, 0. So the solution will be inside the ellipse. Inside the ellipse. All right, so there's no common area because outside the circle, and one is inside the ellipse, so there's no common area. So the answer, the system has no solution. So the system has no solution because there's no common area, no intersection.